Hi everyone, welcome to my online classroom, Algebra 1. This is Chapter 8, Lesson 8, Difference of Squares. Please be sure you use Cornell note-taking, and then we will fill in your graphic organizer next week. Okay, in the past you factored trinomials into two binomials. Now what you're going to do is factor those binomials that are the difference of squares, and those are the difference of perfect squares. And you'll use that difference of squares to solve these equations, and again, you want to remember that you're always solving for the roots. So you only have one real vocabulary word that you need to remember, or vocabulary words, and that's the difference of two squares. This is the factored form of the difference meaning subtraction of two squares. Alright, so the difference of squares is when you have a squared minus b squared, and that will factor into a plus b or a minus b. And the square root of a squared is a, and the square root of b squared is b. So if you look at the next example, the square root of x squared is x, and the square root of 25 is 5. When you FOIL these back together, what you're going to notice is that those two middle terms always cancel each other out. And so let's factor the difference of squares here for m squared minus 64. So if we write it in the form of a squared minus b squared, we have m squared minus 8 squared. I always just take the square root of 64 and say, okay, that's 8. And so I'll have m plus 8 and m minus 8. That's how to factor the difference of squares. And so that's simply your answer. And when you FOIL this back together, you're going to see that those two middle terms always cancel each other out. So let's just do that really quick. M times m is m squared. M times negative 8 is negative 8m. And positive 8 times m is positive 8m. And then a positive 8 times a negative 8 is negative 64. And notice that these two terms right here will simply cancel each other out, and you're left with m squared minus 64, which is what you started with. Alright, so let's go to the next example. And let's factor 16y squared minus 81z squared. Alright, you want to make sure you can either write it in the form of a squared minus b squared, or you can simply ask yourself, what's the square root of 16y squared? Well, that would be 4y. And what's the square root of 81z squared? That would be 9z. And so you would have 4y plus 9z, 4y minus 9z. If you FOIL this back together again, you would get that middle term that would cancel out. And so your answer here would be 4y plus 9z and 4y minus 9z. Alright, let's factor 3b cubed minus 27b. Now, sometimes what you want to make sure that you do is always factor out the greatest common factor before you do anything else. So if the terms of a binomial have a common factor, the greatest common factor should be factored out first before trying to apply any other factoring technique, which is the difference of two squares. So let's factor out the 3b, and we're left with b squared minus 9, which is the difference of two squares, because the square root of b squared is b and the square root of 9 is 3. So you would have this factored to 3b, b plus 3, and b minus 3. Now, this is one of those factoring techniques that you need to memorize. You need to know and recognize the difference of two squares when you see it automatically so that you know exactly how it's factored. Okay. Alright, don't forget you want to make sure you leave the 3b to the front because it doesn't just disappear. You have to have that. Remember that you're actually setting this to 0, and if you divided both sides by 3b, then you would be left with b plus 3, b minus 3. But since that's part of the roots, you need that. So don't forget to make sure you leave your 3b sitting in the front as a factor of this binomial. So let's factor the binomial b squared minus 9. Well, that's simply what's the square root of b squared? B. What's the square root of 9? 3. So I know that one of mine will be b plus 3 and b minus 3. No, it's always going to factor to one being added and one being subtracted, but this is what we call the difference of two squares. And so we can see by this that our answer is C, right here. Let's try another one. Let's do 25a squared minus 36b squared. Alright, this time I'm going to ask myself what is the, I don't really see a greatest common factor that I can take out, but I do see two perfect squares because the square root of 25a squared is 5a. So I know that I have a 5a, and I know that the square root of 36b is 6b. So I'll have 5a plus 6b, and I'll have 5a minus 6b. And so that's the difference of my two squares, so that makes my answer A. I'm trying to kind of delete some of these redundant slides so that you don't have to look at the same thing twice. Alright, let's factor 5x cubed minus 20x. Alright, let's first look at it to see if we can factor out something that's in common. And when I have a cubed and I want the difference of two squares, then sometimes I need to look at it real close to make sure I'm factoring out what they have in common. So I'm going to factor out a 5x. I'm going to take 5x. What do I have to multiply times 5x to give me x cubed? Well, I'll need an x squared minus a 4x. Now, this is the difference of two squares. So keep your 5x, and the square root of x squared is x plus 2. Oh wait, I don't need the x at the end. Hold on. We don't need this x. A little mistake there. Let's see. Oh, let's just start over. Let's see. Let's take out a 5x. Well, fiddle. Hold on. We're going to get it, guys. Hold on. I'm determined we're going to do this. Alright, let's go back to 5x cubed minus 20x. Okay. And let's take out a 5. Let's take out a 5x. And we're left with x squared minus 4. And that's the difference of two squares, because what do I have to do to 5x to get 20x? I would have to multiply it by a negative 4 to get a negative 20x. Okay, this now is the difference of two squares. So keep the 5x, and the square root of x squared is x, The square root of 4 is 2, so I have one that's added and one that's subtracted. Now, there we go. Alright, so let's look and see which one that's going to be. Then that's definitely going to be D. Alright. Now we're ready to go on. Now sometimes you can apply a technique more than once. And that's kind of what we've been doing. Is we will always want to look at it that second time to see if it's something that we can factor again. Alright, so we have y to the 4th minus 625. If you want to write it in terms of a squared minus b squared, the square root of y to the 4th is y squared, and the square root of 625 is 25 squared. So factor the difference of two squares. So you'll have y squared plus 25 and y squared minus 25. Now don't fall for that trick on y squared plus 25, because you know that you can't factor that using this method. But you can factor the difference of two squares, which is y squared minus 25. So you want to apply that method one more time, and you'll have y squared plus 25, which is not factorable by the difference of two squares, but the other one is, and you'll have y plus 5 and y minus 5, which is the difference of two squares. Alright, so let's go through this real quick. This is the same thing we just did. I'm not sure why it's... Okay, and here's our answer at the bottom. Alright, let's look at another one. Let's do 256 minus n to the 4th. Okay, first thing you want to always do is you want to make sure that you're looking at it to see if you have common factors, which you do not. You can write it in the form of a squared minus b squared, and I see that 16 squared minus n squared squared, or the square root of n to the 4th is n squared. The square root of 256 is 16. So I'd have 16 plus n squared and 16 minus n squared. The only one that I can look at and factor again using the difference of two squares is 16 minus n squared. So I'll keep the first one and factor the second one using that technique one more time. Alright, here you have factor y to the 4th minus 16. The square root of y to the 4th is y squared. The square root of 16 is 4. So if I'm factoring this, I'm going to factor this to y squared minus 4 and y squared plus 4. This one I cannot factor, but this one I could factor again because that's the difference of two squares. So I'm going to keep y squared plus 4, just like it is, but I'll factor this first one as y plus 2 and y minus 2. And again, you just need to learn to recognize them for exactly what they are, and that will give you answer D as an answer. Now remember, I could set each one of these to 0 and find the roots, because the whole purpose of factoring is to find the roots of the quadratic. Alright, let's factor 81 minus d to the 4th. So I know that the square root of 81 is 9. I know that the square root of d to the 4th is d squared. So I'll have 9 minus d squared, and I'll have 9 plus d squared. Second one is not factorable again, but the first one is the difference of two squares. And I can factor it to 3 minus d, 3 plus d, and then I have to keep 9 plus d squared. And so that would easily give me an answer of d again. You can multiply in any order, commutative property of multiplication, so I know d is the correct answer. Alright, let's look at another one. Sometimes you want to apply different techniques. So here you have 9x to the 4th, or 9x to the 5th, I'm sorry, minus 36x. Make sure that you factor out what they have in common first. Factor out that 9x, and you're left with x to the 4th minus 4, which is the difference of two squares. Ask yourself, what's the square root of x to the 4th? It's x squared. And what's the square root of 4, which is 2? And you're left with 9x. Don't forget that. You can't just eliminate it. You have to keep it as a factor, times x squared minus 2 times x squared plus 2. And don't get into the trick of thinking that, or the trap that you can factor that using this method, the difference of two squares, because 2 is not a perfect square. And so they're always going to give you things that they think you'll make a mistake on, unfortunately. So you want to recognize that if you have in the a term, in the first term of your binomial, you need a perfect square, and you also need that in the last term for it to be the difference of two squares. They're just showing you this again one more time, so they give you the answer at the bottom. I really think this is probably one of the easier things to do, the difference of two squares, because it's easy to recognize perfect squares. Alright, so here we have factor 6x cubed plus 30x squared minus 24x minus 120. And we're going to factor out what's the greatest common factor, but we're also going to factor by grouping. Remember how we forced that common factor out of the lesson, I believe it was 8-6, where we were factoring by grouping. And so let's run through this. Here's your original polynomial. We're going to factor out a 6 first, and that leaves us x cubed plus 5x squared minus 4x minus 20. And then we're going to group them. Notice how I moved them around to group them with common factors. I know that 20 is a multiple of 5, and that just fit a little bit better. And so I put the 4x with the x cubed because I'm trying to force out common factors. So I took an x out of the first term. That left me x squared minus 4. Now there's the difference of two squares right there. And if I'm trying to force out the same common factor out of all four terms, then I have to force out an x squared minus 4 out of the 5x squared minus 20. So that will leave me with 6 times x squared minus 4 times x plus 5. I still have the difference of two squares that I can factor. The square root of x squared is x, the square root of 4 is 2. So I can still factor the difference of two squares. Always look at what you have one more time and ask yourself, can I factor it one more time? This is just running through it one more time so they can give you the answer at the end. Alright, let's factor 3x to the 5th minus 12x. Okay, the first thing I'm going to do is factor out what's in common. I'm going to take out a 3x. And that will leave me x to the 4th minus 4. So x to the 4th minus 4 is the difference of two squares. The square root of x to the 4th is x squared. Keep the 3x, x squared minus 2, and then I'll have x squared plus 2, because the square root of 4 is 2. Now, I can't do anything with that. That's as factors as I'm going to be able to factor it. Reason being, because 2 is not a perfect square. So, always ask yourself, is it factorable one more time, and do you have the difference of two perfect squares? So your answer here is going to be B. Alright, let's look at another one. Let's look at 5x cubed plus 25x squared minus 45x minus 225. And this one was kind of tricky because I don't see an x in every single term, so I can't take out an x, but I can take out a common factor of 5, and that will help me. So I'm going to take out a 5, which will leave me x cubed plus 5x squared minus 9x minus 45. Alright, and then I'm going to ask myself, okay, I need to factor by grouping since I have more than 3 terms. So I might want to rearrange them a little bit. I might want to say 5x cubed minus 9x, because remember, I'm trying to force it into the difference of two squares, plus 5x squared minus 45. And I want to make sure that I'm forcing out of that the same greatest common factor. So if I have 5 here, and I factor out an x out of the first one, I'll have, let's see, I'll be left with x squared minus 9. Now I know that's the difference of 2 squared. And I want an x squared minus 9 out of the second one. X squared minus 9. So what do I have to do to x squared to get 5x squared? Well, I'm going to have to multiply it by 5. So now I can take out the x squared minus 9, keep the 5. I have x squared minus 9 times x plus 5. Okay, so now what we're going to do is we're going to take x squared minus 9 and we'll factor that. So again, we're going to keep that 5, and then we'll have x plus 3. We'll have x minus 3, and we still have our x plus 5. And so let's see which one is that going to be for our answer then. I believe that that's going to be C. That was convenient. It was right next to it. Okay, so there are quite a few steps, and it does involve using all the techniques that you've used up till now. And this is one of the reasons I really want you to make sure that your graphic organizer is in good shape. You have good examples in there. Any of the examples from this video that you want to add to your graphic organizer, you're welcome to do that, because that is a resource for you, and I want you to be able to use it on the test. Alright, in the equation q squared minus 4 over 25 is equal to y, which is a value of q when y is equal to 0? And why would they even ask you to put 0 in the place of y? Well, the reason is they're asking you to find the roots of that perfect square quadratic. And so if you are looking at this, then you can ask yourself, what's the square root of q squared? what's the square root of 4 over 25? And I simply do it this way. I just ask myself, okay, well, I've got q plus 2/5, and I have q minus 2/5. And if I'm setting that to 0, then I'm setting each one of these to 0, so I would have q would be equal to a negative 2/5, and q would be equal to a positive 2/5. And so they don't give me both of the answers, but they do at least give me one of the answers, the negative 2/5. So you want to make sure you read that test item as the difference of squares, and then solve that test item, replacing that y with a 0, and you're writing it in the form of a squared minus b squared, difference of two squares, factor the difference. You're using that 0 property product. You're actually setting it to 0 to solve for the roots. And so you get q is equal to negative 2/5 and q is equal to positive 2/5. Right, and so again, here we are. The roots are negative 2/5 and positive 2/5. So when x or q is negative 2/5, then y is 0. And when x is positive 2/5, y is 0. So the correct answer is D. Alright, in the equation, m squared minus 81 equals y. What is the value of m when y is equal to 0? Well, I just simply look at it and say, okay, that's the difference of two squares. Even if I take out y and put in 0, that's the difference of two squares. So the square root of m squared is m. The square root of 81 is 9, so I have m plus 9 and m minus 9. If I set each of those to 0, I'd have m is equal to negative 9 and m is equal to positive 9. Now they only give me a negative 9 as an answer here. I think the better answer would be if they had, like for B, they'd had positive 9 and then said D was both B and C. So you need to make sure that you're remembering that there are really two roots here. They just happen to give you only one answer. That might be something that might happen on the Aspire, and so you have to choose the best answer. Okay, that's the end, and your assignment will be on the board. I'm pretty sure it's going to be on page, let's see, I'm thinking maybe 519, 15 through 43 odd, and on page 520, 48 through 55 odd. Make sure you show your work. Thank you and have a great day.